Mic on. Sorry for those that turn the mic on. Sorry if you're watching the video. Alyssa Jensen. All right, so A union C, you should have from -2 to 6. So open circle, close circle. And if you do C, you're from -6 to 1. So 1 and then -6. So you want to be, you don't have to be part of both of them. You just got to be part of one of them. So is -10 part of one of them? No. How about -5? How about 0? How about 3? How about 10? So it looks like from -6 to +6, that's the set. Let's try A intersection B. I've already got the graph drawn. A intersection B means where they overlap. They must be part of both. Look at this graph right here. Is -3 part of both? No. How about -1? How about 3? Yeah. 3 is part of both, right? How about 7? So it's this region here. So A intersection B is going to be from 0 to 6. That's the overlap. I want you on your own to try B intersect C. See if you can come up with B intersect C. I would encourage you to draw the graphs and look at the overlap to see where the sets are. Again, I'm encouraging you to make the graph because seeing things visually helps you understand things mathematically. Which is what I don't get, because when we get to graphing, everybody's like, I don't like graphing. But we all learn visually, so we should learn to love graphing. Okay, let's see what we get. We've got B to C. So I'm going to mark down B. I got 0, closed circle to infinity. Everybody good with that? And then C is going to be -6 to 1. -6 to 1. And it's a closed circle on the 1. So it looks like the overlap, again, I've got different colors so it's easier to see, but it looks like it's just this region right here. So your intersection is from 0 to 1, and that's it. Questions on that? It's supposed to be a funny problem, so thank you for the laugh. I appreciate that. What's that?
What if I put the graph here and then answer it there?
That's fine. Yeah. Yep. Okay, so here's what I want you to do. I want you to take 5 minutes. I just handed you a worksheet. Just look at the front side of it. Okay, we're going to get to exponents and radicals in a little bit. Okay, give you a little bit of time to work. On your worksheet, you can see, look at number 3. Number 3 says, graph the set and express it as an inequality. Express it as an interval, not an inequality. Interval, not inequality. Interval. Go ahead, take some time. Okay, take out your notes. Let's open to this piece. Exponents and radicals, exponents and radicals. I find that for many students, exponents and radicals happen to be one of the biggest struggles that they have. I would expect that 95%, so 19 out of every 20 students in class would have at least 2 questions on this assignment, okay? So if you fly through it, you got no questions, you are the anomaly. Good for you, must be great, being smarter than everybody else. Chances are, if you fly through, you don't have any questions, you made mistakes, you did not ask questions on it. Okay? If you're used to getting all the problems right, good for you. That's amazing. Okay? In this class, you're probably going to make some mistakes. You're probably going to have to ask on it. You want to be challenged in certain ways, especially after a little bit of a disrupted last year, right? So let's figure it out. Let's deal with our exponents first. 4 cubed. 64. How do I calculate if it's a -2 to the 5th? Is it -2 times -2 times -2 times -2 times -2? Or is it 2 times 2 times 2 times 2 times 2 and you attach a negative? Which one is it? The top one or the bottom one? It is the bottom one. Okay? So in this situation, you get -32. Extremely important that we understand this piece, okay? I'll write out this next one, and then we'll try to make sense of it all together. Notice what's different about letter C is that you have parentheses, right? That means that the negative is being included with the cube. So it's -3 times -3 times -3. -3 times -3 is 9, times -3 is -27. So Here's the question that sometimes people get. They get negative 3 squared, and they get negative 3 squared. What's the bottom one? 9. Right? This is 9, correct? What's this? Negative 9. Yet some people will say that those are the same statements. That is not correct. Okay? This is rather negative 9 attached to negative after. Letter D, anything to the 0 power is?
0.
Very good, it's 1. Why is it 1?
Because you're taking pretty much the first power, or not the first power. Pretty much everything that is some square that is being. I have to give up saying.
Thank you for your honesty. Does anybody know why if you take something to the 0 power, you get 1? Ooh, wow. Oh, they just made it up.
Yeah.
Nobody ever makes anything up. We all draw it from somewhere. 3 to the 9th over 3 to the 9th. You know that when you divide, you subtract the exponents, right? Everybody agree that that's 3 to the 0? And yet, if you take something divided by itself, it's... So therefore, anything to the 0 is 1. That's why. That's why. Okay? Just want you to understand. All right, E, square root of 144. Can you take the square root of a negative?
No.
No, you get imaginary, don't you? Can you take the cube root of a negative?
Yes.
What's the cube root of negative 125?
Negative 5.
Negative 5. Because negative 5 times negative 5 is 25, times negative 5 again is negative 125. So you can take the cube root of a negative. Fourth root of 81. What do you multiply by itself 4 times to get 81? 3. What's different about letter H? And I have negatives, don't I? Oh, no. So if I have a negative exponent, what do I do with it? I drop it to the denominator. And I have 1 over 3 squared. So I have 2 cubed over 1 times 1 over 3 squared. What's 2 cubed? Over? Letter I. 1/3 to the 3rd power. 1/3 times 1/3 is 1/9 times 1/3 again is 1/27, which is why you could take a fraction and you could raise the numerator to the power and the denominator to the power. Times 6 squared is 36 over 27. Both are divisible by what? 9, which gives me 4/3. Letter J. Whitney's smiling at the problem. I think she's got an idea. What do you want to do?
So, I want to do 5, or the square root of 5, and then split up the 45 to the square root of 5, square root of 9.
Well, I like that, because the square root of 5 times square root of 5 is 5. And square root of 9 is 3, which is 15. Now, there's another way to do it. What is 5 times 45? 225. And what's the square root of 225? It's 15. See how you have 2 ways to do it? So let's use Whitney's way for this one again. Square root of 3 times root of 3 times 3 times what is 48? Starts with a 6, rhymes with teen. Good. 16. Root of 3 times the root of 3 is? And root of 16 is? So I get 12. Yeah. So we can use that property of radicals. Try letter L on your own. Go. Letter L. Yeah, so the 2 to the negative 3rd, you drop that 2 to the 3rd to the denominator. It gives you 8 in the denominator. And then the 4 to the negative 2, you bring in the numerator, get 4 squared, which is 16. So 16 over 8 is 2, which I saw most people come up with. Good. Flip it over. Oh, yeah. Okay, if we want to add or subtract radicals, can you just add or subtract those right away?
No.
What must you find? Common radicans, right? The radicans have to be the same. So what's a perfect square divides evenly into 18? 9 times the root of 2. Good. Root of 9 times the root of 2. Minus, perfect square goes evenly into 200. Good. 2 and 100. Square root of 9 is, so I have 3 roots of 2 minus 10 roots of 2. Now what is 3 roots of 2 minus 10 roots of 2? Negative 7 roots of 2. Good. What's different about problem B? Yeah, we got cubes instead, right? So you're used to thinking of these, right? You're used to thinking of perfect squares, right? But if you see an index of 3, that means you're looking for the perfect cubes. 1 is a perfect cube, so is 8, because 2 times 2 times 2 is 8. What would be another perfect cube? 27. Thank you, Luke. What's another one? 64. 125. 216. So on and so forth. I'm sure you have them memorized, right? Good job. Very proud of you guys. A little grid in the room. Just make a poster, just like, just tape it to the ceiling so when you go to sleep at night, you can just stare off into the land of numbers. Very good. What's the perfect cube that divides evenly into 16? 8. 8 goes in how many times? So I have the cubed root of 8 times the cubed root of 2 plus 2 times the cubed root of, what's the cube root that perfect cube goes into 250? 125. That goes in twice. Great. Cubed root of 8 times cubed root of 2. That simplifies 2. 2 cubed roots of 2. Luke loves math. Love it. Cubed root of 125. 5 times 2. 10. 2 cubed roots of 2. 10 cubed roots of 2. 12 cubed roots of 2. It's like fun to write it because we've never written it before even. First time for everything. Hi. This guy?
Yeah.
From right here. So the cube root of 8 is 2. And then we leave that one alone because you don't have a cube root of 2. Better?
Yep.
Excellent question. Thank you for asking. Try C and D on your own. C and D on your own. Go. Gadget, go. All right, let's try it. Here we go. 3y squared, 4y to the 5th. I've got 12y to the 7th. Anybody get that?
Yep.
All right. Question? Or you just want a high five? Air 5, there we go. All right, the next one. I see negative exponents, so I'm going to move them to where they are not. Okay? So that means a to the 8th stays on the bottom, but everything else moves, right? So a to the 5th comes to the bottom, b to the 7th goes to the top, and b to the 3rd goes to the bottom. So notice on the bottom, a to the 8th and a to the 5th make a to the 13th. And if I'm dividing, then I subtract, I get b to the 4th on the top. So b to the 4th over a to the 13th. You're almost there. I know. Hey, I'll give you partial credit. We're going to try something new this year on tests. The problem is either all right or all wrong. Should we do that? No.
Oh, no.
I'm kidding. All right. Letter E. Where do you want to start? Where do we even start? With the cube. Yeah, exponents. Thank you. Let's start by cubing this guy. So does that mean I take 2 times 3, or do I cube 2? I cube it. So I've got 3xy to the 4th times, good, 2 cubed is 8, then x to the 12th, y to the 9th. Excellent. So I've got those two pieces now. Now, easy peasy, right? 3 times the 8 is the 24. What do I do to the exponents? I add them. I get x to the 13th, y to the 13th. Yep, that's all right. Adding is tough. I get it. I'm right there with you. what about letter F? What would you do first? Yeah, so this negative sign right here, let's get rid of this negative sign by flipping everything. So I have 2x to the negative 3, y to the 4th, over x cubed, y cubed, quantity squared. So all I did is use up the negative on the outside exponent by flipping everything. What do you want to do next? You want to get rid of that negative guy right here. Okay, so we're going to go 2y to the 4th over x cubed times y to the 3rd squared. So Ella said drop that negative down. I like it. Now what?
Use cube up or use square up.
Okay, we could do that. Does anybody want to deal with these x's and the y's first? Okay, so we're going to have 2y in the top, x is 6, and that's all to the second power. Now can we square it? 4y squared over x is 12. That's it. Let's see if we can handle G and H, and we'll leave the rest for tomorrow. And again, I think that this is possibly the most challenging assignment of your first unit. People struggle with radicals and exponents.
So what does that mean for our back page on these? Like how many of these problems can we do on the back page?
As many as you can. When you can't, just put it aside.
Just do as many as you can.
Yeah, and to be clear, all of it you've learned before. So you might be able to handle it.
You don't have to do every single one of these by tomorrow?
Not by tomorrow, no.
Okay.
Letter G. Would everybody agree that letter G looks complicated? Because when you see fractions, your brain just goes to dirt, right?
Yep.
So if you don't know how to do the problem, do an easier problem. Watch. What if it was negative 2a to the 3rd times 5a to the 4th? Would you know what to do there? You would take negative 2 times 5 is negative 10, and what would you do to the exponents? Well, let's do the same thing. So negative 2 times 5 is negative 10, a to the, I need to add the exponents. So that's 3/4 plus, what is 3/2 as fourths? 6/4, and that makes 9/4. Look at how smart you are. Look at that. We took something with fractions, we made it easier. Last one we try for the day, it says 4x to the 6, y to the 8th to the 3/2. What if it said 4x to the 6, y to the 8th to the 3rd? What would you do to the exponents there? You would multiply, right? Power to the power, you multiply. So let's just multiply then. Look at the x. 6 times 3 divided by 2. 9. 8 times 3 divided by 2. 12. Now 4, though, we have to take that to the 3/2 power. So that means 4 to the 3rd, then take the square root. That's what that means. What's 4 to the 3rd? 4 times 4 times 4? 64. What's the square root of 64? 8. Something that you guys might forget, if you had, say, 4 to the 5/3 power, what that means is the cubed root of 4 to the 5th. This thing sticks with the top. This is your index that goes out front. Do you remember that a little bit? All right, we get a big time no back here. That's all right. We'll do our best, okay? So definitely want to try a few problems there. Try to make sure you can figure out what you know tonight and what you don't know so that tomorrow we can go over a couple questions together. We'll give some more time to this before we move on to our next piece. Good job today. Happy birthday to Maddie. Enjoy your practices, everybody.